Okay, so in this video, I'm going to be going through while I'm writing out the solutions for assignment 7. And the hope is that some people who may find that the solutions are a little difficult to read, hopefully that this video explanation, the video and the audio component will help. So without further ado, we're going to go through section 11.2. This is the fundamental theorem of calculus, and the first exercise says to evaluate the following definite integrals. So for 1a, it says it's the definite integral from minus 6 to 7 of 2 dx. So the antiderivative of 2 is 2x. So if I differentiate that 2x, if I take the derivative of that, the derivative is just 2, which gets us back to the original. So that's good. And here is my limits, the minus 6 and 7. So in this case, what I need to do is I'm going to evaluate the function, the 2x at 7, minus, and the function at negative 6. So it's 2 times 7 minus, and then I'm going to evaluate this at the function at minus 6, so it's 2, and then I substitute in the minus 6 in here. So now I can evaluate this. 2 times 7 is 14. I have 2 times negative 6, so that's minus 12. And the minus 12 with the negative here gives me positive 12. Okay, 4 and 2 gives me 6, and 1 and 1 gives me 2. So it gives me 26. And if I check at the back, yes, indeed, it is 26. So that's the end of that exercise. For the next one, I have part C to do. For part C, I have the integral from 1 to 2. And it's 5 plus 4x minus 6x squared, and that's dx. Okay, so I apply that integral for each of those terms. So what I can do is I just integrate. So the antiderivative of 5 is 5x. The antiderivative of 4x is, put the plus. So what I do is I have the x and it goes up a degree, so it becomes 2. And I also write the fraction here, so there's a 2 that goes down at the bottom. And then I also write down that 4. Next I have x squared. So again, that goes up a degree, so it's going to become x cubed. There's also a 3 that comes down here. And I also write that 6. So if you notice, if I differentiate this, it gets me back to this original side here. So if I take the derivative of 5x, the derivative of 5x is 5. Boom, it's right there. I have, if I take the derivative of this, x squared, 4 half x squared. Well, if I take the derivative of that, it goes down a degree, and so it becomes 4 times, and then there's the 2 comes down, so it becomes 2, and those 2's cancel, so I'm left with that 4x, good. And same thing, this drops down a degree, so it becomes x squared times 6, and then also I have that 3 that comes down, so those 3's cancel, so I'm left with 6x squared, good. So, and don't forget my limits of integration. Then I'm going to simplify this so that I have 4 over 2. Well, that's just 2x squared. 6 divided by 3 is minus 2x cubed. Same limits, 1 to 2. And then now evaluate this function at 2 minus this evaluated this function at 1. So I have 5, and I substitute it in 2, plus 2 minus, and then here's the function at 2. Okay, and then I have minus the function evaluated at 1. So I'm going to write these square brackets in here. And what I'm going to do now is substitute 1 now into for x. So I got 5 times 1 plus 2 times 1 squared minus 2, 1 cubed. So I got 10 plus 2 squared is 4, so 4 times 2 gives me 8. I have 8 cubed, so that's 8 times 2 gives me minus 16, and minus, so I leave that in the brackets here, so 5, that's plus 2, minus 2. So those, the 2 minus 2, those cancel. So I'm just left with 10 plus 8 minus 16 minus 5. Okay, so 10, so I got 8 minus 16, so 8 is half of the 16, so that gives me the minus 8 minus 5. So 10 minus 8, that gives me 2 minus 5, so that gives me minus 3. Okay, and good, I got the same answer at the back, so I can move on. So for E, for this one, I have the integral from minus 1 to 2, and for this one is x squared, oops, no, it's x cubed minus x squared plus 4x. Okay, so on this one, I have, so integrating that, it's 1/4 x to the 4th. This one is minus 1/3 x cubed plus x squared. And for my coefficient, I have 4 divided by 2. So that gives me 2, and that is from minus 1 to 2. So I substitute those values now into it, so I get 1/4 times 2 to the 4th minus 1/3 2 to the 3rd plus 2 times 2 to the squared, then subtract. Get a minus 1/4 times negative 1 to the quarter, or sorry, to the 4th, minus 1/3 1 to the 3rd plus 2 times 1 squared. Okay. Okay, so 2 to the 4th is 16 minus, I have 1/3 times 8 plus, I have 2 squared, so that's 4, so I'll write that in there. Okay, so minus 1 to the 4th is positive, so I'll leave that alone. The 1/3, and then this is minus 1 to the 3rd. So what that is that's 1 minus 1 times minus 1 times minus 1. So that I have a negative times a negative gives me a positive, times a negative gives me a negative. So boom. Okay, so that's a negative 1 here, so I have a negative out front here, so this gives me a plus 1/3. And -1 times -1 gives me just positive. So there's a positive up front, so that's just +2. Okay, so 16 divided by 4, that's just 4. I have 8/3. Leave that as a fraction for the moment. +8 minus 1/4 minus 1/3 minus 2. Okay, so move that up. Okay. So I have 8 plus 4 gives me 12, minus the 2 gives me the 10. So that's good, that's good, that's good. Okay, and then I have the -3. Okay, and then I have a 4. So what I should do is, let's write this all over the common denominator of 12. So that means that if I want it over 12, I'm going to have to multiply this by 4. So that gives me the 12. 4 times 3 gives me 12. And then the 8 times 4 is 32. Minus 1/4. So instead of 1/4 in this case, the 4 times 4 gives me, or sorry, the 4 times 3 gives me 12. And so that means I have to multiply on the numerator the 3. Then I have, instead of the 3 here, this is going to be 12. So multiply this by 4, which gives me 4 on top here. And hopefully this works out into a nice number. So 32 minus, okay, so I have -7. 32. Okay, so minus, okay. Oh, sorry, that's a minus and minus. So that means that I have 35, 39 over 12. Okay, and so if I keep going, well, it looks like I'm going to have to write this over 12 as well. So 10 times 12 is 120 minus 39 over 12. So 120 over minus 39. 1. And then 11 minus 3 is 8. Oops. Is that 81? 81? 81 over 12. And let's see, if I can divide that by 3, 81 goes, okay. So then that's 12. If I can divide that by 3, that means that 3 goes in. There's the 4th. And 81 divided by 3 is 27. Just make sure 27 times 3 . 21. Yep. Perfect. So I got that to match the same as what's in the back of the book. So that's good. It's a little tedious in terms of the arithmetic, but doable. Okay. Here's the second page. So, E, let's move on to 1G. So in this case, I have the integral from 2 to 3 of 1 over t squared dt. Okay, so let's rewrite this into a form that we can use. So 2 to 3, and we'll use t to the minus 2 dt. So if I integrate this, it's going to go up a power. So that's t to the minus 1, and the minus 1 comes below. So this just comes down in here, and that's minus. And now this is from 2 to 3. And so I get, well, it's minus, and it's actually still 1 over t. Here's my 2 to 3. So substituting in, I get minus 1 over 3. And then in this case, I have a minus, and I still have a minus from this part here. So minus 1 over 2. And so that equals minus 1/3 plus 1/2. So write this over 6. So I'm finding a common denominator, 6. So in this case, it's a, I'm multiplying by 2 to get to this. So 3 times 2 gives me 6. So in this case, it'd be minus 2 up top. And in this case, I have 2 times 3 gives me 6. So in this one, it'd be 3. So I'm left with 3 minus 2, which gives me 1/6. Good, and that's what we have at the back of the book. Okay, so what else? I have H. For H, I have the integral, the definite integral from 1 to 4, x minus the square root of x dx. Okay, so now the antiderivative of x is, oh, well, see, we know what the antiderivative of x is, so that would be x, 1/2 x squared. Not so sure about the square root of x, but what we should do is rewrite this so that we can apply the kind of reverse power rule that we've been using. So let's do that. Just rewriting this. X to the 1/2 dx. And now we can do this. So this becomes 1/2 x squared minus, and then I have x. So this is going to go up a power. So this is 1/2 plus 1. So that is 3/2. And that comes down in front here. So that becomes 1 over 3/2. And that's from 1 to 4. Now from this, we can just kind of rewrite this to make this nicer. So 1 over 3/2 can be rewritten as 2 over 3 x 3 over x to 3 over 2. Okay, and now I I calculate this function at 4 minus this function at 1. Okay, so 1/2 of, and then we substitute in 4 for this. So 4 squared minus 2 divided by 3, and not x, but we're going to replace it with 4, 3 over 2. Then subtract it from this function evaluated at minus 1. So I get 1/2 times 1 squared minus 2 over 3 times 1 3 halves. So I get 4 squared, that's 16 divided by 2. So that leaves me with 8. 4 to the 3 halves. So 4 to the 3 halves is equal to the square root of 4 to the 3rd. And so four cubed is, so 4 squared is 16, and then I do times it by 4 again. So 16 times 4 gives me, is that 64? Yeah, that makes sense. So square root of 64, and square root of 64 is 8. Okay, so and in this case I have 1/2 minus 2/3. Okay, so I have 8 minus, and then I have 8 times 2 is 16 over 3. Minus 1/2 minus 2/3. So what I'm going to do is I'm going to get 8. So this is minus 16 minus 2. So that gives me minus 18 over 3 minus 1/2. Still doesn't give us a nice answer yet. So we're going to have to write this over 6. So 2 times 3 gives me 6, so that's 3 up top here. And 3 times 6 gives me, 3 times 2 gives me 6, so 18 times 2 16, carry the 1, 2, so 36. So that gives me 8 minus 39 over 6. And still doesn't give me a nice answer yet. So H, okay. And let's see. Well, if I multiply by 6, 8 times 6 is 48. 39 over 6. So 48 minus 49 gives me 17 over 6. And that's what the answer at the back of the book is. So good, we matched it. On to the second page, or third page now. So I've done H. So this is 1I. Okay. In this case, it's the integral from 0 to 1. And I have square root. And this is the fourth square root. X to the fifth dx. So again, this is quite difficult to handle at the moment. So what we'll do is we'll rewrite this using our exponent law. So that's equivalent to writing x to the fifth over 4. So 5/4 dx. Okay. And so what this is going to be is, if I use my power rule now, so it's going to be x 5/4 plus 1. And in the bottom here, it's going to be 5/4 plus 1. And my limit's from 0 to 1. And so what this gives me is x to the, I think it's, so if it's this plus 1, so I write it as like, say, 4 over 4. And so 4 plus 5 gives me 9, so that's 9/4. And in the fraction here, that would also give me 9. The 1 over 9/4 from 0 to 1. And I can rewrite this again. So I can flip this over. So I got 4 over 9, x to the 9/4 from 1, or from 0 to 1. And so I'm actually kind of lucky because I can rewrite this. So it's 4/9, and substituting in my value 1 to the 9/4 minus 4 over 9, 0 to the 9/4. So this goes to 0. And 1 to the 9/4, that's 1. So I'm just left with 4 over 9. So let me just check. 1i. Yes, indeed. That's what the answer is at the back. So good. I have 1i, so let's do 1j. So this one is the integral from 1 to 8. And here's 2 divided by the cube root of x. This is dx. Good. So I can rewrite this again so that I can apply the power rule again. Okay, so because I have this in the denominator, that's where the minus comes from. And just using my exponent rules, x, the cubic root of x is equivalent to 1/3. So that's, I have the 1/3, and because it's in the denominator, it's the minus. And then here's dx. So now I can do the antiderivative now. So it's 1/3 plus 1. And then I have my 2 divided by, I have my minus 1/3 plus 1. And I'm going to integrate from 0, or from 1 to 8 in this case. Okay. So I have a negative 1/3 and I have 1. So just think of it, I have a whole pizza and I ate 1/3, so I'm left with 2/3 left over. And so I have 2 divided by, and again, my 2/3 here, from 1 to 8. Okay. So I'll just simplify this here so that I get, well, let me just use a different pen over here. So in this case, the 2 over 2/3 is equal to 2 over 2 times 3. And the 2 cancel, so I'm just left with 3. Oops. So I'm left with 3x 2/3 from 1 to 8. So I get, now I plug in these values. I have 3, and then I substitute in here. Here's my 8. 2/3 minus 3 times 1 to the 2/3. So 8 times 2/3. So I will do the squared first. So 8 squared is 64. And then we need to find the cubic root. And we know that, let's see, 2 cubed is, 2 cubed is 8. So 4 cubed is 64. So it's, in this case, it's 4. So I get 3 times 4 minus, and 1 to the 2/3, that's still 1. So I'm just left with 3 here. So I get 12 minus 3, and that leaves me with 9. And that's the correct answer at the back, so that's good. So 1J, okay, now moving on to 1K. Okay, so I have 1 to the 2. Okay, so that's my limits of integration. X cubed plus x squared plus 1 divided by x cubed. And here's dx. Okay, so this is quite hideous to work with. So what we're going to do is we're going to simplify it first. So what we'll do is, here we go, 1 to 2, and I have my x cubed divided by x cubed plus x squared divided by x cubed plus 1 over x cubed dx. Then the next one is x cubed over x cubed, that just cancels, so that I'm just left with 1 plus, and then I have x squared over x cubed, so that just leaves me with 1 over x plus, and I have x cubed dx. Okay, so in this case, if I integrate this, oh, well, in this case, this is also that 1 over 3. The 1 over x cubed is equal to x minus 3. Okay, so what I'll do here is I'll start to do the antiderivative. So the antiderivative of 1 is just x. The antiderivative of 1 over x is ln, so that's according to from our rules in that table of the indefinite integrals. So all you have to do is just looking through here. It was one of our rules right here. So there it is, the integral of 1 over x dx is equal to ln x. Because remember, in this case, this power rule here, I can't use it when n is not equal, or when that n is equal to -1. So I can't use this. I have to use this one instead. So that's equal to ln x plus, and then I have -1. So this will become x to the -2 over 1 over -2. And that's from from 1 to 2. So substituting this in, I get 2 plus ln 2 minus, this is the 1/2, times 2 to the -2. And here's the minus. So here's 1 plus ln 1. And then minus 1/2. Substituting in here is the 1 minus 2. There we go. So I get 2 plus ln 2. And 2 to the -2, so that gives me 1 over 2 times, so in this case it's 2 squared, and that goes into the denominator, so that's 4 minus 1, and ln of 1 is 0, and 1 to the -2 is still just 1, so that becomes 1/2. So I get 2 plus ln 2 minus 1/8 minus 1 plus 1/2. Okay, so then I get 2 minus 1, so that gives me the 1, just 1 left over. And then I have 1/2, so that gives me 3/2. And then, so I have 3/2 minus 1/8 plus ln 2. So that equals, I guess I'll have to rewrite this over a common fraction. So in this case, to get to 2 to the 8, so it's 2 times 4. So 3 times 4 gives me 12. So that gives me 11 over 8 plus ln 2. And let's just check. Yes, and that's what we got at the back of the book. So that's good. So this is page 4. Okay, so I have K, L. This is 1L. Oops, I'm going to flip back to my page that I was working on. So 1L. So here's the integral from 1 to 4. It's the square root of x plus 1 divided by x. Okay, so again, I'm going to simplify this first before I start to apply any of my rules. So, x to the 1/2 divided by x plus 1 over x dx So this means that I have x to the minus 1/2 because I have the 1. So the 1/2 minus 1 gives me minus 1/2 plus the 1 over x here dx. And now I can integrate, or well, find the antiderivative. So x, so I have minus 1/2 plus 1, so that's going to give me 1/2. And then I write the 1 over, and then there's the 1/2 plus, and then the 1 over x is this is the case where I can't use the power rule. I have to use the ln function. So I get ln x, and use my limits of integration from 1 to 4. So I have 1 over 1/2, so that's equal to just 2 here, so that's why. So I'll just rewrite that again. 2x, so here's the square root, plus ln, and I have x from 1 to 4. And so I get 2 square root of 4 plus ln 4, then minus 2 square root of 1. Now remember this, let's use our brackets. So it's this whole function at 1. So it's 2 square root of 1 plus ln 1. Now ln of 1 is 0. And so we get 2 square root of 2, okay, sorry, 2 times the square root of 4, so that's, this one is 2, so this is 2 times 2 gives me 4. The other thing is in this case I have ln, this is 2 to the 2, and minus, the square root of 1 is 1, so that's 1 times 2, so that's just 2. And so I get this. 4 plus ln 2 squared minus 2. So I'm going to write the 2 in front of the ln here. And I get the 4 minus 2. That gives me 2 in front here. So in fact, depends on how they write it. I can factor out this 2 here. So I can get 1 plus ln 2. Okay. Oh, I got a different answer than what's in the back of the book. So in the back of the book, we talked about this in class, that depends on who's writing it. But in the back of the book, all they did was they did the same thing. So what they got was this is equal to 2 times 2 gives me 4 plus ln 4 minus 2. So then they got 2 plus ln 4. So that's right as well. And these are equivalent answers. Okay, so we're almost done number 1, the first exercise. So I have 1L, and now I have 1, let me just check this, 1M, good. 1M. This is the integral from 0 to 64 of the square root of y, 1 plus the cube root of y dy. Okay, so we need to expand this out. So I get the square root of y plus, and then I have the square root of y multiplied by the cube root of y dy. And then let's convert these to exponents. So I get y to the 1/2 plus I have y to the 1/2 times y to the 1/3 dy. Now remember, when I'm multiplying these together, I have to add the exponents. So 1/2 plus 1/3 gives me, I have to write them over 6. So again, to get to 6, I have to multiply this by 3. So there's 3 plus, and then in this case, I need to multiply that by 2. So that becomes 2. So it's 5/6. Okay. Okay, so now I can find the antiderivative in this case. So 1/2 plus 1 gives me 3/2. Then 1 over 3/2. But then I can rewrite that as 2/3 plus. Now in this case, it's 5/6 plus 1. So 5/6 plus 6 over 6. So that is 11. 11 over 6. And then that's 1 over 11 over 6. So that is 6 over 11 from 0 to 64.